Hello everyone and welcome to our webinar Secure Unsigned PDFs in Blazor, Master Digital Signatures with the Syncfusion .NET PDF Library. I'm Sriram Shankaran, Senior Product Manager at Syncfusion, and I'm excited to guide you through the powerful features of the Syncfusion .NET PDF Library and how it can transform your Blazor Server applications. Today, we will dive into the world of digital signatures and PDF management in Blazor. So whether you're building secure document workflows or enhancing your .NET applications, this session will show you how to seamlessly sign and validate PDFs using Syncfusion's high-performance PDF library. So here's what we have planned for the next hour. We will start with an overview of the Syncfusion .NET PDF library and preview the exciting hands-on demo, outlining the digital signature and validation techniques that we will explore. I'll then walk you through signing and validating PDFs in a Blazor Server app, showcasing practical code and results. Following which, we will have the key takeaways, and finally, we will wrap up with your questions. Okay, before we jump into coding, let me give you a sneak peek of what we will cover in the live demo. So the Syncfusion.NET PDF Library is a feature-rich framework that lets you create, read, edit, and sign PDFs. So it's perfect for Blazor developers looking to add robust document management to their apps. So in today's demo, we will just focus on the digital signature part in a Blazor Server application. So you'll see how to sign an existing signature field in a PDF document, complete with a custom appearance. Then we can see how to sign with an external signature, which would be ideal for automating signatures with an HSM. And we will also have a look at how to leverage the Windows Certificate Store for secure managed certificate signing. Then we will see how to create long-term validation signatures that remain valid even if the certificates are revoked. And finally, we will have a look at how to validate signatures both individually and against a trusted certificate list to ensure document authenticity. Coming to the prerequisites, before we begin, ensure you have the latest version of the .NET 8 or .NET 9 SDK installed along with Visual Studio 22. Okay, now let's move to the demo. As the first step, let me open Visual Studio 22. The project that you see on screen is a new project created by me of type Blazor Server app. With respect to the changes already made to the project, let's start with the packages. So I've installed the Syncfusion PDF.NET Core NuGet package as a reference to the Blazor application. And I've also installed System Security Cryptography PKCS NuGet package. So the usage of which will be discussed as we move to the coding part. Under the www root folder, the various PDF files to be used as part of this demo and the PFX files have been added. So let's move to the data folder. Here I've created a new CS file named exportservice.cs and included the following namespaces in the file. I've also created a button in the index.razor file using the code which I'll show now. Let's open the index.razor file. So this is the code and I've defined its on-click event. I'll just highlight it for you now. So this invokes the JavaScript action to download the PDF file in the browser. Next, we'll move to host.cs HTML file, which contains the logic related to the save as file JavaScript function. Finally, I've registered the Syncfusion license key in the program.cs file. So the details I'll just show you in the documentation, and all of it can be found in Syncfusion's document processing documentation as you can see on screen. Okay, first I will show you how we can sign an existing signature field in a PDF document. Before that, we will have a look at the PDF file which has an existing signature field. I'll just proceed to open it. The file that you see on screen is an example workshop registration form. So as you can see, it has the necessary form fields along with a signature field. Okay, let's move to the coding part. As the first step, I'll define a method called signExisting with a memory stream return type and add the code to sign the existing PDF document. So I'll just proceed to code that. Okay. So within this method, I'll retrieve the file location using the web hosting environment variable and read it as a file stream from the specified location. Let's have a look at the code. I'll then create an instance of the PDF loaded document class and initialize it with the file stream object. Okay. So now I'm going to add a digital signature to the document. So to do that, I'll get the signature field instance from the document fields collection and store it in the PDF loaded signature field variable. So let's start coding that. First, I'll start with the form. So PDF loaded form, followed by the page. Next, we will have the PDF loaded signature field. Okay. Then to add the signature, I'll create a PDF certificate using the PFX file and its password. There you have the PFX file. Now the certificate. So we'll just pass the PFX stream and the password. Okay. So following that, I'll create a PDF signature using the certificate and assign it to the signature property of the signature field instance. Sorry. Okay. Then I will define a standard font with a name and size to display the text in a custom style. So I'll just go ahead with PDF standard font. The font family would be Helvetica and we'll define the size. Next, I'll proceed to draw the signature on the PDF page, which involves drawing text and shape using the signature instance. But before that, I will get the graphics instance of the field and I will use a signature field bounds to draw these elements. So starting with graphics. Okay. Next, I will draw a rectangle shape and the text to describe the signature. Let's have a look at the code. So we will pass the necessary arguments. Now that I have completed adding the signature, let me save the document to the stream and return the saved stream. So I'll just proceed to add the necessary code for that. Okay, so with that done, we will just call this method in the create PDF function, which is sign existing. Okay, now let's run the application to check the output of this particular code. Let's download the file, which is creating the PDF. There you go. The signature is added to the field, and we will just have a look at the shape and text too. So they are also added for the signature. As you can see, the signature added is valid. Now what we will do is we will try to modify this PDF file, for which I'll just open this file in Notepad++ and make some random change to it. So what I will do is I'll just add a space and save it after the signature has been added. So with that done, I'll just open the same file now. As you can see, the signature has become invalid. Next, let's have a look at how to sign a PDF document with an external signature. For that, I'll just navigate back to Visual Studio. So the method I'm creating now is called external signature. Now I'll just load a PDF document that has no signatures. We will use a different PDF file for this scenario. So in this case, if you need to automate this signing process, if you need to automate the signing process for many documents on a server with its own HSM, this particular method can be used. Okay. Then I'll add a signature by passing the null value to the certificate argument. Okay. So here the signature object has an event that allows us to create a certificate and embed the digital signature into the PDF document. For that, now let me define the compute hash event handler. So I'll just proceed to add the necessary code. Okay. Now let's get the document as a byte array. I'll be using the sign CMS class to create a certificate and the CMS signer class to sign it. So these classes are already available in the system.security cryptography NuGet package, which we install. So for that, I'll now import the required namespaces to use both these classes. So let's proceed to add the namespaces. There you go. So then I will initialize the sign CMS instance with the document byte array. Okay. So now let's create the certificate using the PFX file and its password. You have the PFX file over here. Next, I will initialize the CMS signer with the created certificate and set the digest algorithm to it. So following this, I will compute the signature using the compute signature API, where I will encode the digital signature and embed it into the PDF document. So first let's compute the signature using the compute signature API, followed by which we'll do the encoding. Okay. Now I'll just call the compute hash event within the external signature method. So let's move to the external signature method and call the compute hash event. Let's save the document to the memory stream and return it as usual. Okay. We will now comment the call to the sign existing method in the create PDF method and call the newly coded external signature method. Okay, let's run the application. I'll just create the PDF. Let's navigate to signature panel. So you can see the newly added signature and its details listed over here. And as mentioned here, the signature is invisible. So another secure way to store the digital ID is by using the Windows Certificate Store. For this, we need to retrieve the digital ID X509 Certificate 2 from the Windows Certificate Store and use it to add a digital signature to a PDF document. So let's look at the steps to sign a PDF document using the Windows Certificate Store now. I'll just navigate to Visual Studio and we'll create a method called Windows Store. Now I'll just load the existing PDF document. We can use the code from the already available methods. Okay. Then I'll create an instance for the X509 store using a specified store name and store location. Okay. Following this, I will get the existing certificates from the store in an X509 certificate to collection variable, retrieve the first certificate from the collection, and use it to create the PDF certificate. So let's proceed line by line for each of these steps. First would be to get the existing certificates from the store in an X509 certificate to collection variable. Next, we'll retrieve the first certificate from the collection. And then use it to create the PDF certificate. Okay. Now I'll create the signature using this digital certificate. So again, we can make use of the code available in the already existing methods. So I'll just copy it from here and make a single change alone. Instead of null, I'll provide certificate over there. So following this, the usual process of saving the document to the memory stream and returning the stream. Now I'll comment the code for external signature method and call the Windows Store method. Okay, let's run the application and check the output of this code. Okay, let's create the PDF. Okay, let's wait for the signature panel. Yeah, there you go. As you can see, the signature is marked as valid. Next, I will show you how to sign a PDF document with long-term validation. So once a PDF is signed with an LTV signature, it will be valid for the long term, even if the root certificate is revoked. So let's navigate to Visual Studio. And we'll define a new method called LTV. So the first step would be to load the PDF document and add a signature to it. So again, we will make use of the code available in the existing methods. Okay, so then I will set the required signature properties. So the first one would be cryptographic standard. Next, the digest algorithm. And then we will add a timestamp to it. Now I enable the long-term validation by setting the enable LTV property to true. Following this, I'll save the document to the stream and return the saved stream. Okay, next to the usual process of commenting and adding the new method. So Windows Store will be like commented, and we will add LTV method over here. Sorry. Let's create the PDF. As you can see, LTV is enabled. And let's have a look at the signature properties. The signature standard is set to BLT. So with that, I walked you through the different ways you can digitally sign a PDF using Syncfusion .NET PDF Library. Next, I'll show you how to validate the existing signatures in a document. Let's navigate to Visual Studio. As the first step, I'll create a method called validate PDF signatures. Okay. Now let's load a PDF document with multiple signatures in it. I'll just make use of, again, the already available code. Just the file name would be different. It will be changed to multiple signature. Okay. So the validate signatures method is available in the PDF loaded form field collection class to validate all the digital signatures in a document. So let's proceed to code related to that. So I'll now create a variable for the list of PDF signature validation result, and it will have the information about each digital signature and its status. And I'll name it results. So using the validate signatures method, I'll validate the signatures in the document. So this method will return true if all the signatures are valid. If any one of the digital signatures is invalid, then the result will be false. So now to the usual process of copying the memory stream code and adding it over here. Now what I will do is I'll just add a breakpoint over here to show the validation result at runtime. Okay, the application is running. Sorry, I forgot to comment the already available method and add valid signatures over there. So let's comment LTV and add validate signatures. Let's create PDF. As you can see, all the signatures are valid. Let's have a look at the signature details in the file. So the signature details are available over here. Now let's look at the scenario where I want to validate individual digital signatures. So for that, we will just navigate to Visual Studio and I will comment this code to validate multiple signatures, and I'll proceed to add the necessary logic. Okay, so with this code, it iterates the form fields in the PDF document, and if it is a signature field, it will get the signature field instance. And after that, it uses the validate signature API to validate the signature. So now let's add a breakpoint to show the validation result of each signature. Let's again create the PDF. If you look here, each signature is marked as valid. The second one, there you go. So next I will show you how to validate signatures against a trusted list. So I can create and pass my own trusted list of certificates to validate a digital signature in a PDF document using the Windows Certificate Store. So for that, I'll just create an instance for the X509 store using a specified store name and store location, and get the existing certificates collection from the store in an X509 certificate to collection variable. So let's add the necessary code for that. Okay. So now that the code has been added, I'll just change the valid signature API with an argument, which should be the certificate collection, so that the signatures will be validated using it. The breakpoint is in place already. So let's run the application. And create the PDF. Let's check the is signature valid property. It's true for the first one, and it's true again. So let's check the output of the code in the file itself. So as you can see, the signatures are marked as trusted and valid in the PDF document. And with that, we have reached the end of our demo. So before we wrap up, let's recap what we have covered today. We learned how to load a PDF with an unsigned signature field, apply a digital signature using a PFX certificate, and enhance it with shapes and text for a professional look. We explored two secure methods, that is, automating signatures with external certificates for high volume scenarios and using the Windows Certificate Store for managed secure signing. We also enable LTV to ensure signatures remain valid long term. This would be perfect for archiving critical documents. And finally, what we did was we validated multiple signatures at once, checked individual signatures, and used a trusted certificate list to ensure authenticity. So these techniques, what it does is that it empowers you to build secure, efficient PDF workflows in your Blazor applications. And with that, we have come to the end of this session.